Alright, and we are on to the last section for the week, 11.2, and I'm calling it a supplement. This is not in the textbook, but it is the surface area of prisms and cylinders. Okay, and so here's two things that we haven't talked about before. We don't exactly know what a prism is, and we don't really know what a cylinder is. You should know, but we might not. Now, this was all maybe understood content from the book's perspective, but I feel like this is something that's worth going over. So first off, a prism is going to be defined by a solid object with two identical ends and flat sides. So for example, if you had a cube, right, so you have a square on one end, it's going to be a square on the other end. I'm going to try to draw this all nice in 3D. I'm going to butcher it, and I'm sorry. Okay. Now it has flat sides, so basically you connect these, and you end up with something that on each end, not the best picture I've drawn, on each end has, the same object. There's that square on the ends, right? And it has flat sides. So basically any shape on the end here, you can put a triangle there, you can put a hexagon there, connect them. These are all like basic art projects that you do, right? All of those are going to be prisms. This would be a rectangular prism, for example, okay? And so basically we're looking for the surface area of what that shape would be. And now the difference between surface area and area, right, is that surface area is three-dimensional. These shapes are three-dimensional shapes. Instead of taking the area of a square or of a circle, I'm taking a shape, like my coffee cup here, and I'm finding the area of the shape that actually is there, right? So in this case, it's like a Kleenex box. I'm taking the area of this Kleenex box in some way, shape, or form. Okay? So in this case, I'm going to define the surface area of a prism as the sum of the areas of all the faces. So simply put, surface area is the area of the outside of the object. And so it's not really too terrible. If I actually gave you this Kleenex box right here, and I wanted you to find the area, I would say, hey, let's go ahead and fold it on one side, find the area of this side, right? Take length times width, that would be the area. Switch sides, find the length times width here, and do that for all 6 different sides, and that would be the surface area. So that's all we're going to do here for the prisms, okay? We're just going to find the area of all the faces, and we're going to give them names, like for this Kleenex box here, quote unquote, top and bottom, left and right, and back and front. Those are going to be the 6 sides that we're going to call them. We're going to find all those areas, and then we're just going to add them up, okay? Now, there are formulas for these prism surface areas. If you Google surface area of a prism, you will find a formula. We're going to go ahead and not use them. And the idea behind that is that I would rather just look at it and understand it intuitively what's going on than just say, hey, here's the formula, here's how you do it. Okay? So there's going to be 6 areas we need. We need the area of the top, area of the bottom, area of the left, which is in the back side there, right? If that makes sense. Area of this left side. Left, area of the right side of the box, if you can imagine holding it, and then area of the back and front. I'm going to back and area up front. I should probably just write this all out, huh? Right, left, bottom, top. There's 6 sides, 6 different areas. Now, what we need to do, those areas are very simple. Remember, the area of a rectangle is just base times height, right? Or length times width. So for the top and the bottom, right, if this is 4 and this is 2, up here this is also 4 and 2. So for both the top and the bottom, the area would be 4 times 2, which would be 8. Now you're going to notice all the opposite sides are going to match, right? The top and the bottom are going to be the same area and so on. All left and right will be the same area as well. So for the right one, we have a 6 on the up and down and 4 over here. So it would be 6 times 4 for both the left and the right, which is 24. Okay. And for the back and the front, we have 2 and 6, right? And this is a 6 right here. And so that would be 12. 2 times 6 is 12. And so would the front. Okay. So to find the surface area, we just need to add them all up. So 8 plus 8 plus 24 plus 24 plus 12 plus 12. Don't need a calculator. We got 24 plus 16. That is 40. Plus 48 is 88. I should check that. Just in case I'm wrong. 8 plus 8 plus 24 plus 24 plus 12 plus 12. 88 indeed. 88 inches squared. Again, this is still an area. I'll put SA for surface area, and that would be good. Okay? But all we did there is find the area of all 6 sides there, not outside the realm of what we are capable of doing. Okay? We'll do it once more. A little bit more challenging here. So we still have 6 sides, right? We have, well, do we have 6 sides? Actually, we don't. We have 1, 2, 3. So left, right, and bottom, and then the back and the front, right? So this is, it looks more like a tent, if you will. So we have 5 different areas to find here. But the challenge here is that the area of any triangle is not just base times height, it's 1/2 of the base times the height. Now this picture's nice, right? This triangle has a height and a base for you, and so it's doable. But depending on the challenge that you have for the kind of the base figure here, if you will, it's going to change the difficulty of the problem. So I'm going to put area of the front triangle, area of the back triangle, and then I'm going to put area of the left, area of the right, and area of the bottom. Okay, so front triangle, back triangle, left, right, and bottom. Now, the front and back triangles are going to be the same, right? So we have area of the front triangle. It's 1/2 of the base, which is 6. Base times the height, which is 4. So that's for both of these triangles. Oh, I put everything in parentheses, I guess. Just one of those days. 6 times 4 is 24. Half that is 12. So they're both going to be 12. Okay. Area of this left side, now these are rectangles. These are easy, right? Base times height. So if this right here is kind of what we need, now this is going to be 10. They're all going to be 10 here. So we have 5 and 10, so it would be 5 times 10, which is 50. Over here, the right one's 5 times 10 still. That's also 50. But the area of the bottom is going to be a little bit different, right? It's kind of spread out further. We're going to have 6 on the bottom and then 10. So it's actually going to be 6 times 10. Which is 60, okay? Now to find the surface area of the shape, we simply add them all. So we have 12 plus 12 plus 50 plus 50 plus 60, 24 and 100, 124, 184. I'm not going to check that one. Just very confident. But simply put, if you have a nice, nice boxy shape, if you will, like a nice prism, all you got to do is find the area of each side, add them up. That easy, okay? On to one that's a bit more challenging. So the surface area of a cylinder. Now, I would argue that it's the same idea, right? If you took a cylinder, think of it as a pop can, right? A cylinder is this shape right here. It looks like a pop can. It has a height and it has a radius, right? It's kind of 2 circles on the ends and a side in between. Now, I challenge you, if you have time at home, go ahead and take like a soup can or something with you right now and hold it up. All right, so hopefully you have a can at this point. I have pinto beans, okay? And so this diagram right here is going to show us how to find the surface area. But the easiest thing to think of is that we have a top and a bottom, and then this middle part in the middle, which is kind of round, right? So look at my can. This is definitely a cylinder, right? You can see what I've already done here. But it has a top, has a bottom, then has this round piece, okay? And so if you're going to deconstruct this, what you do is take the label off, right? So on the top is obviously a circle, right? Right here's a circle. And in the bottom, we have a circle. And we know how to find the area of a circle from today, and so that part's easy. We have 2 areas of circles. But what is this middle piece going to be? So if you take off the wrapper of your can, you will find out that you actually get a rectangle. Okay? See, I kind of tore it a little bit, but it's a perfect rectangle. And so the only thing that's challenging here is, this is obviously the height, right? If I put this back on the can, the kind of the width of this thing is just the height of the can, right? But what is the actual length of this can? That's a question you kind of got to know, right? What is this length? Because this height right here is just the height. But what is this length? And so that's what the challenge is. It turns out if you actually look at it back on the can, the length all the way around is just the circumference of the circle, okay? And so the only challenge here is going to be to find the circumference of a circle. But what we're going to do is we're going to break down each cylinder into the top circle, the bottom circle, and then this thing called the lateral area, which is the area of that wrapper, or the label that I just took off. And the base area of each circle is going to be pi r squared. Okay, so there's 1, 2 of those. Okay, and then there's this lateral area, which is going to be the length times the width of that wrapper. Well, we said that the width was just the height of the can, and the length is the circumference of the circle, which we will use 2 pi r for. So circumference of the circle. Okay? And so we have 2 pi r squareds. So in this big formula, we have two different pi r squareds. That represents the top and the bottom circle. And this is the lateral area, which is 2 pi r, that's the circumference of the circle, or our length here, and h, which is our height. So this right here, I have little spots now, this right here is going to be the formula that we're going to use for the surface area of a cylinder, okay? Kind of just showed you where it came from. If you don't really understand that, you can ask me, but mostly it's just this diagram breaking it apart. Grab a can of beans and see if you can figure it out on your own, okay? So let's go ahead and use this. Find the surface area of a cylinder with a radius of 4, so r equals 4, and a height, or h, equals 3, okay? So we can actually just plug everything in here. Surface area equals 2 pi r, we know r is 4, h is 3, plus 2 pi r is 4 squared, okay? Just this formula plugged right in. So we get 2 times 4 is 8, times 3 is 24 pi, plus 4 squared is 16, times 2 is 32 pi. You can actually add the pi's together, or just take it times 3.14 right now if you want to. So you would get 56 times pi, which is 3.14 in this class, 175.8 centimeters squared. Remember, this is surface area, okay? So that's just using this formula right here. And we're on to our last question. We want to find the surface area of this old school looking can of motor oil, okay? So again, we just have the radius and the height. Our surface area formula was 2 pi r h, circumference times height, plus 2 times the area of the circles on top and bottom. So we have 2 pi, the radius is 5, and the height is 15, plus 2 pi radius of 5 squared. And we can go ahead and multiply those again. So 5 times 15 should be, what, 75? Times 2 is 150. So in the first one we have 150 pi plus 50 pi. We end up with 200 pi. And 200 times 3.14 is 628. Why does that seem wrong? It's not wrong. Of course it's not wrong. So we get surface area equals 628 centimeters squared. Just using that formula that we talked about, okay? Hopefully you understand where those formulas come from, and you can solve some of that. We will get on to surface areas of cubes and of cones and other shapes soon, but I just thought this was important to talk about. There will be no homework with this section, but if you watch this, I appreciate it. Have a good day.